Bardakci and Bengisu Duru Goksu. We are here to present to you our UI for Anomaly Detection in Time series. In the first page of our UI, the landing page, we have the AstroSense documentation that details the use cases, available models, workflow, and the methodologies used in financial anomaly detection and earthquake detection methods, and technical specifications. So let's, before wasting any time, get into the Start Training button. Here we get into the training laboratory. We can pick from any model architecture and this selected data set, earthquake and financial market, and you can see the details of the training data on this section here. For our demo purposes, I will pick 1D CNN. As you can see here, there's a default recommended amount of epochs for the earthquake data. This is because for our demo purposes, we want to be able to pick less epochs to train faster so that we can showcase our work in this video. So for this case, I will only train this model for 4 epochs, but we can already see that the default was 30, and it is also recommended that we train it for 30 to 4 epochs with early stopping. So let's click on the Start Training button. As you can see, the epoch number here has been updated based on our selection, and the model is being trained. And as it's being trained, training loss and validation loss are detected in the graphics. And as it goes, it also calculates accuracy, F1 score, and loss values. So using the user-trained model or the pre-trained model, the user can select whichever one they'd like to run some tests. The user-trained model is the model that we have just trained now for 4 epochs. From here, we have several options for threshold methods. Once you click on each, there's a small description about what it does and how it does it. And you can also select a custom threshold value. We made this so that people who are expertise in this field can enter their own threshold values. So for now, I will enter a random value of this and run test inference. So here's the test results we have gotten. As you can see, accuracy and precisions are quite low. This is because we've only trained the data for 4 epochs for this demo purposes. And here are some performance metrics overviews and reconstruction graphics, and the ROC curve for the accuracy results and the confusion matrix. So the users can see visually how well the model has been trained. Now we will move on to the financial data.
On the financial market side, you can select a stock. The stock and the date are selected, and then the data is pulled from a Y-Finance library using Y-Finance API. So if I select a different date, it will just pull a different data. For example, every time we select something different, the data is being pulled dynamically. So now we will use the pre-trained model for test. We actually have pre-trained models for all of the models. So now they are the best that these models can become. In here for finance side, the threshold is determined with a MET-K value and the stress percentile, and this can be changed. So let's run an inference test. In here, as you can see, this is a pre-trained model with the default values. So this is the best this model can get, and that's it. Thank you.
Thank you.